All right, good people, we're back. We're going to pick up where we left off with this more on the functions and graphs section. In this part of the section, we're going to look at piecewise functions. Piecewise functions. So a function that is defined by two or more equations over a specified domain is called a piecewise function. In this particular example, we have the problem where we have cell phone plans. It says that a cellular company offers the following plan. $20 per month buys 60 minutes. You know, this is kind of old because we don't buy many minutes like this anymore. An additional time costs 40 cents per minute. So it doesn't matter. Anywhere from 0 to 60 minutes, you're going to pay $20 a month. But if you go over $20 a month, that's where the second equation comes in. Then we're going to pay an additional 40 cents per minute. So we're constant here at $20 per month. And then if we go over that 60-minute mark, then our cost begins to increase depending on how many minutes we talk over 60 minutes. Okay, so let's look and see how we could solve a piecewise function depending on what we're given. So the same function here, we're asked to find and interpret each of the following. We want to find and interpret the function when we talk 45 minutes, when we talk 60 minutes, and when we talk 90 minutes. So if we use up 45 minutes, well, that's between 0 and 60. So no work needs to be done there. I know my cost is going to be $20. If we use up 60 minutes, that's still okay within our original condition because this says t is greater than or equal to 0 or less than or equal to 60. Therefore, that still fits the first condition of $20. However, on this third one, we talk for 90 minutes. We use 90 minutes. So since we're using something that's greater than 60, we need to use this equation that goes with that expression. So we would write this out, replacing t with 90 minutes because that's how long we talked on the phone. And then we have this simple expression here to evaluate. So order of operations tells us that we need to first simplify inside the parentheses, which 90 minus 60 will give us 30. Multiply that 30 times 0.4. So 30 times 0.4 will give us 12. So if we use up 90 minutes, if 90 minutes are used up, then our bill will be $32. Okay, and that's it. Okay, so let's look at another problem like that one. All right, so we're going to evaluate this piecewise function. We have f of x equals 3x plus 5 if x is less than 0, or 4x plus 7 if x is greater than or equal to 0. So we look at the number in the parentheses that represents our x values. And this first one, we have f of negative 2. Well, negative 2, is that greater than or less than 0? That's right. It's less than 0. So that tells me to use the first function there. So we'll use expression 3x plus 5, replacing x with negative 2 because our x was less than 0. So f of negative 2 equals, order of operations, 3 times negative 2 is negative 6, plus 5 is negative 1. Okay. What about f of 0? Well, is 0 less than 0 or 0 greater than or equal to 0? Well, 0 should be greater than or equal to 0, so we will use that second expression. So we have 4x plus 7, 4 times x plus 7, replacing the x with the 0 value. And then again, we evaluate. So 4 times 0 is 0, and 0 plus 7 is 7. So when x is equal to 0, the value of the function is 7. And last but not least, we have f of 3. Well, again, we ask ourselves, does it fit condition 1 or condition 2? Well, since 3 is greater than 0, then that fits condition 2. So we'll use the second expression again, replacing x with 3. Order of operations, multiply, then add. 12 plus 7 is 19. Alright, and that's all we're going to do with those piecewise functions. The next thing that we're going to look at is functions in difference quotient. So we're going to look at the difference quotient. And you will see that in the definition, in the derivative definition, when you begin your calculus journey. So functions and the difference quotients. So the difference quotient is the expression f of x plus h minus f of x, all divided by h, for h not equaling 0. That's called a difference quotient. So we're going to be given a function, and we're going to be asked to find the difference quotient. We'll use this expression here and use substitution for that function to find the difference quotient. Alright, so I kind of broke this down to a first step and a second step, and we'll call that step 1. So we have the function f of x equals 2x plus 1. And we want to find the expression or the difference quotient f of x plus h minus f of x, all divided by h. So you may find it helpful first to find f of x plus h. So f of x plus h tells us to take the original function, and wherever I see an x, I'm going to replace it with x plus h. So I had 2 times x instead of 2 times x. We want to have 2 times x plus h. Then what do you do with that? Well, simplify it. Use your distributive property. So 2x plus 2h plus 1. So now I can take that piece of information, I can come over here, and that'll help me out a little bit because I already know what f of x plus h is. It's 2x plus 2h plus 1. So I can replace that f of x with 2x plus 2h plus 1. And then it said minus the original function. So the original function f of x was 2x plus 1. So minus 2x plus 1. All divided by h. Now, you're going to take this and you're going to simplify this as well. Now remember, when you have a minus in front of a set of parentheses, you treat that as negative 1 and you distribute. So the opposite of 2x plus 1 is minus 2x minus 1, all divided by h. Simplify some more. We have 2x and we have a minus 2x. Those cancel each other out. We have a plus 1 and we have a minus 1. Those cancel each other out. So that simplifies to 2 times h divided by h. And the h divided by h would cancel each other out, and that would give us the final result of 2. And that's using the difference quotient. So you follow that same routine, that same pattern, and you simplify, and that's how you use the difference quotient. So let's look at one more of those. Let's try it again. There we go. So now, this one we have find and simplify the expressions if f of x equals x squared minus 4. So again, the first thing that we're going to find to help us to simplify the expression a little bit easier, we're going to find part of it. We're going to find x plus h, f of x plus h. So my original function was x squared minus 4. So I put parentheses squared minus 4. And wherever I have an x in my original function, I'm going to replace it with x plus h. All right, now again, I think we saw a problem like this earlier. This takes us back to algebra, multiplying binomials, and we had a plus b squared, and the quick way to do that would be the first term squared plus 2 times a times b plus the last term squared, b squared. So that's how we're going to multiply that out. Oh, I need to correct this. Sorry about that. So f of x plus h there. Alrighty, so f of x plus h equals x squared plus 2 times h times x plus h squared. That's multiplying out using that rule up there. And then minus 4. Alright, so I can't simplify that anymore. So now I'm going to take it and use it on the other side. I'm going to find f of x plus h. Well, I've already found that part, so I'm just going to rewrite what I just simplified. X squared plus 2hx plus h squared minus 4. And then I'm going to subtract the original function, minus x squared minus 4 all over h. Follow the same process. Remember to distribute. So minus x squared plus 4 all over h. And then combine like terms. So we have an x squared and a minus x squared. Then we have a minus 4 and we have a positive 4 that cancel each other out. So now we're left with 2hx plus h squared all over h. Alright, so since we have h in both of the terms of the numerator and we have an h in our denominator, let's factor out an h. So if I factor out an h from 2hx, that gives us 2x. If I factor out an h from h squared, that leaves us with h all over h. Now, that allows us to finish simplifying this. H divided by h would cancel each other out. And my final result would be 2x plus h. Alright, good people. I hope you found this video to be helpful. I appreciate you taking the time to listen to me. Have a good one.